Hello, let's begin our class. I updated the quiz results and you can take a look. I also updated the accuracy results of assignment 4. And the deadline of assignment 4 is today's midnight. And I also updated the accuracy results of assignment 5. And you can have a look. And if your accuracy is below 100, this means there is an issue with your program. And you can test all of the input-output samples. And I added some samples. I added one sample for the add command, and three samples for the cut command. So you can find the added samples at the end of this page. So you should pay attention to when the scores, when the leaderboard has two scores, the same two identical scores. So here the leaderboard has a score 93, and then the user add another item with score 93. Then according to the rule, this one should be placed above the one already in the leaderboard. So here Cho should be placed in before Ada. So this is according to the assignment's rule. So you should pay attention to this case. And I also add some samples, additional samples for the cut command. For this command, the leaderboard has only one item, and if the user inputs cut 32, then all the commands are set to score 0. And some students' program does not pass this test. And also, I also add sample 5. For sample 5, here we have the leaderboard, and all the scores are above 75. So if the user input cut 75, then this will have no effect on the leaderboard because 75 is below the minimal score. So the leaderboard remains the same. And some students' program is not able to deal with this case. So if your accuracy is below 100, then you can test all of the input-output samples. And for our final exam will be the next week because December 25 is a national holiday. So we need to move up our final exam. And the rule for final exam is similar to the midterm. It's a paper and pencil exam, closed book. Calculators and mobile phones are not allowed. And the exam scope includes materials covered between November 6 to today. And I will post the seating chart on that day. And today we will do a roll call when the second class begins. And in the previous week, we already learned structures. And this week, I will finish classes and constructors. So let's here PDF 1 is for structures and classes, and PDF 2 is for constructors. So in the previous week, we already learned structures. We can define our own data type, and then this week we will learn classes. Classes is also for defining our own data type, but classes are more powerful. Besides member data, we can also have member functions, and we can also have additional attributes like public and private members. Structures in C programming language only have public members. So in C programming language, you cannot protect your data. If you want to protect your data, you need to use the private attribute. And C++ introduces the class feature. The reason is to support object-oriented programming. So we will briefly mention about object-oriented programming. And one of the key principles is to separate interface and implementation. So class is similar to structures. We can use classes to define our own data type. And this is the central part of object-oriented programming. And we call in C++, we call variables of class type as objects. So objects are actually variables. So here is one example. We define here class is the keyword similar to struct, and we use this keyword to define our own data type. And besides member data, we can define member functions. So here we have one member function output. This function has no input because inside the parentheses is empty, and this function returns nothing. So the output data type is void. And we can use the dot operator to access member data and also access member function. So the difference between member data and function is, for function you need to add parentheses. So this slide is about how to define the member function. So we put the function declaration inside the class definition. So inside the class definition, here output is only the function declaration, and for function definition is outside the class. So the function definition is usually outside the class definition. And to define the member function, you will need to use the scope resolution operator. This is a double column. So here you need to add the scope resolution operator. And this is to tell the compiler this function belongs to the day of year class. So that the compiler know this function belongs to day of year class. And then one feature for this member function is you can access all the members of this class. So inside the output function, we can access month and day, where month and day are the member data of this day of year class. So this is very different from the functions we have learned, because previously for functions, if you want to deal with variables, you need to send data through the function input, or you need to declare data inside this function definition. And for member function, you can directly access member data of that class. So here we can implement this. You can implement this member function. So for this example, you see, I use this data type to declare an object date. Then you can access its member function or member data. So here I call the member function output, and this member function will print the member data month and the day. But because I didn't initialize the member data, so you will see months and day are some random numbers, and then I assign some values to months and day, and you will see the output. This member function will show the months and day. Month is 12 because I set months to 12 before the output member function. The next slide is about the public and private attributes. And previously, we only use public attributes. So here, we put all member data and member functions under the public attribute. This means you can access this member function or or member data outside the class. However, if you set member data to private, then you cannot access the member data outside the member function. So this means you cannot access member data inside the main function, because main is not a member function of that class. So this will cause syntax error. So you see here, month is private, so you cannot access months in the main function, because main is not a member function of that class. So here you can only access private data inside the member function. So within output you can print months and day. So here this line shows the initial values of months and day. And usually for object-oriented programming, we usually put member data under private attribute. This is because we want to hide data. We do not want user to directly access our data. So usually member data is under the private attribute. And you can only access the data with member functions. And the member functions can be either private or public, depending on your tasks. So for structures in the C programming language, all members are public, and structures only have member data and do not have member functions. And for C++ classes, we have member data and member functions, and you can also you also have the public and the private attribute. The next slide is about accessor and the mutator for the class. Accessor and mutator are both member functions. The accessor is to read member data, and the mutator is to change member data. Because we cannot directly we do not want to directly access the member data, so the member data is under the private attribute. And if we want to access or modify the member data, we need to use accessor and the mutator. So here is the function declaration of the accessor. This function has no inputs, and this function returns the member data day. So because day is an integer, so this accessor returns an integer. So this depends on the data type of the member data. So and for the mutator set day, and we want to modify the member data day. So the input is the value to replace day. So the input will have the same data type as day. So the input is also an integer. And this function does not return any value, so the return data type is void. And the implementation is very simple. Here, get day, you only return the member data day. And for the mutator here, we set new day is the function input. So you set new day to the member data day. So here you can try to practice how to implement these functions. So for here, I implement the. This is the mutator. I implement a mutator. So this mutator will modify the member data day. So after this function call, day is set to 11. So you see here we have a syntax error, and this is because I do not use the scope resolution operator. So the compiler does not know set day. This function belongs to this class. So here you need to specify this function belongs to day of year class. So you see, after this function call, the member data day is set to 11. So here, day is set to 11. And because I do not modify months, so months remains a random value. And you can also implement set months to modify the value of months. So after the mutator, month is set to 12 and day is set to 11. Next, we will have a quiz. And if you need the answer paper, please raise your hand. You can only through member functions. You can only through this member function. Yeah. So here you can access private member data.
I will access the private there in the menu.
Yes, you cannot. You cannot access private data here. So for the first question, you need to determine which sequence is not in alphabetical order. Uh, 30 seconds left. I will turn on the second question. This is about pick and get functions. And suppose the user enter the following line A, B, C, D, E. The user enter 5 characters, and you need to determine the value of the output. Output is a string, a C++ string, and you need to determine the value of output after the above statements. 30 seconds left. Then I will turn on the third question. Suppose we use an unstable sorting algorithm to sort the following strings according to the length of a string, and then you need to determine what are the sorting results. Uh, 30 seconds left. And I will turn off all the questions. And if you use answer paper, please submit answer paper to me. Let's see the answer to question 1. So the second second sequence is not in alphabetical order. So here bend and the benefit, we see the first three characters are the same, both are bend, and the fourth character T is after letter E, so bend should be after benefit. So for the second sequence, this sequence is not in alphabetical order. And you can check the remaining three sequences are in alphabetical order. For this question, we need to determine we need to determine the value of the output. So you see inside this for loop, the C++ string output is concatenate to a character. So after each iteration, one actor will be added to this C++ string. And we need to know the value of ch at index I. So ch0 is A because user input A, and the peak will not move the pointer. So after peak, the pointer still points to A. So the next statement, the get will read the character pointed by the pointer, and now the pointer points to A, so ch1 is also character A. And the get is different from peak. Get will move the cursor, so now the cursor get will move the pointer, so now the pointer moves to the next character B. And we use peak, and peak will return B because pointer points to B, and B is assigned to character 2. And the peak does not move the pointer, so pointer still points to B. And when you call cin.get, you will get B. So the answer to this question is the first one. And if you are not familiar with the two functions, you can refer to the reference web page, and you can find under the strings item. Here is one video to explain the get, pick, and the putback function. Oh, you all know the result of the of this question. So here we use the unstable sorting. Unstable means you cannot guarantee the relative order after sorting. So here we want to sort this sequence according to string length. So the shortest string will be placed in the beginning. So the shortest string is Bill and Alex. They are both of length 4. And both of the three are correct sorting results according to string length. And because we use unstable sorting, so we cannot guarantee the relative order. So you cannot say Bill is before Alex. So the answer to this question is all of the above are possible. And if you use stable sorting, so here if you change this question to stable sorting, then we will have a unique answer. So the answer should be should be the first one if you use stable sorting, because you need to guarantee the relative order. Alex is after Bill, and Yolanda is after Zitella. If no questions about a quiz, then I will return to our course website. And school requires us to conduct teaching evaluation, and we have 2 surveys. The first survey is for the EMI course. And the second survey is for student learning outcome. So we have 2 surveys. One is for EMI course, and the other is for student learning outcome. And after you finish the survey, you can take a break for 10 minutes. And when the second class begins, I will do a roll call. It's around 10:11. Hello, let's continue our class. And next, I will do a roll call. So if I call your name, please raise your hand. Mei An. OK. 汤秉琪、简以安、黄进成、庄成佑、尤成汉、陈于晴、许世伟。陈正瑞、许志瑞，here I introduce a class. A class is actually you can think class as a data type. So for a data type, for example, for integer data type, integer has its own internal data. It need to support for example, to store the 32-bit integer. And this data type also need to support operations like addition, subtraction, multiplication, etc. And you can regard each operation as a member function. For example, the addition operation takes two inputs. You add two numbers, and the result of this operation is the return value of this member function. So the addition operation will return the results. The results is also an integer. So you can regard each operation as a member function. So this is the same as class. So for class, we have member data and the member functions. And in object-oriented programming, data types are abstract. This means the users of the data type do not need to understand how this data type is implemented. And for example, you use the C++ string, and it is very convenient. You can use plus to concatenate two strings, but you don't need to understand how the concatenate operation is implemented. So this is abstract data type. The users need not know the implementation details. So this is our goal. Our goal is to hide the implementation details, and the users only need to know the interface. Actually, this is a key principle for object-oriented programming. And another principle is to separate interface from implementation. To use a class, the user only need to know the interface. The user don't care about the implementation. For example, suppose we use the sort function to sort an array of integers. You only know the interface about the sort function. However, you don't need to understand which algorithm is used in the sorting function. The sorting function might use bubble sort, quick sort, merge sort, any sorting algorithm. But as an user, you don't need to worry about which algorithm. So this is another key principle for object-oriented programming. We usually separate interface from implementation. And the benefit is if you change the implementation, your users do not need to modify their code. Suppose the implementation of the sort is modified. And because the interface remains the same, so you don't need to modify your code. So we usually adopt this principle. So the principle of object-oriented programming is to hide your data, to hide the details, and also to use the private attribute to hide your data. Because we do not want the users to directly access your private data. And this slide is about to compare procedure-oriented programming versus object-oriented programming. For the C programming language, is usually use procedure-oriented programming. You see the global data is shared between functions. So in POP, procedure-oriented programming, we cannot protect the data because all functions can access this data. However, if you want to hide your data, then you can consider use OOP, object-oriented programming. And both paradigms can be used for programming. This depends on your task. So depends on your task. You can choose POP or OOP. But I think the important principle is clean code. No matter you use POP or OOP, you should always write clean code. Clean code means your code is easy to understand and easy to maintain. And therefore, your code, if there is some bug inside your code, you can quickly find the bug. So I think clean code is more important than which paradigm you use. And we have finished this chapter. And then I will go to our next chapter is about constructors. You can open the PDF tool. The first part is about the introduction of constructors. The second part will introduce some tools for the class. Constructors are actually a special kind of member function. This member function will be automatically called when an object is created. So constructor is a member function. Its purpose is to initialize objects. So here is one example. We can define our own. We can define a constructor. So here, constructor is a member function. So you see a parenthesis. So it is a member function, and it is very special because its name is the same as the class. So the name of the constructor is the same as the class. For this example, they are all day of year. And so this is the first remark. The name of the constructor is the same as the class itself. And the second remark is constructor returns nothing. So and you don't need to write void. So you see this function returns nothing, and we don't need to write void. if you write void, this will cause syntax error. So inside this function, we do not use the return keyword. So this constructor is just a member function, and the inputs can be arbitrary. It can be empty. So you can design your own constructor. And here we want to initialize the two member data. So I let two inputs. So here I have two inputs because I want to initialize the two member data, months and day. So here, so inside the implementation, we use the input value to modify the member data. And the constructor is usually public because we want to declare objects inside the main function. So usually constructor is public. So here, when you declare an object, and if you want to call the constructor, then you need to follow by a parenthesis. This is like to call a function, make a function call. So so this is called implicit. This is the implicit way to call a constructor. So here we declare this object date1 followed by a parenthesis, and this will invoke the constructor. So here this will call the constructor day of year, and the two inputs will be used to initialize the member data. So here I declare two objects, date1 and date2, and each object has its own member data. So the member data are independent for the two objects. So here date1 has its own month and day, and the date2 has its own month and day. The two member data are independent. So here you can try to practice how to define our own constructor. So here I implement this constructor. So inside this class, we put function declaration. So this is the function declaration. This has the same name as the class, and this function does not return any value. So here is the implementation. We have two input parameters. And we use the two input parameters to initialize member data. So here, now suppose we want to call the constructor, we need to use the parentheses, and here we need to specify two inputs because our constructor has two inputs. So here you see month is set to 12 and the day is set to 11. So here we cannot directly modify member data inside the main function because here month is private. So you cannot modify this member data inside the main function. You can only modify the member data inside the member function. Output is a member function of day of year. So you can modify private data inside member function. However, you cannot directly call the constructor like this. We know that one is an object. You cannot directly call the constructor like this. That one dot day of year. This is syntax error. This is syntax error. Next, I will introduce another way to initialize member data. You can initialize member data inside braces. You can also use another method known as initialization section. So for this method, we add a column after the parentheses. And after the column, you can set member data followed by a parentheses. So here, after months, we assign month value to months. So you can use this syntax to assign value to member data. And method 2 is very common because method 2 is easy to understand. So we can modify our constructor using initialization section. So here I modify the constructor. After the column, I initialize months. So this new month is the first input. The first input is assigned to the member data months. The second input is new day, and new day is assigned to the member data day. So you see here, after this constructor, month is set to 12 and day is set to 11. And the constructor can have additional purpose. For example, not just initialize data. We can also validate the data inside the constructor. For example, you can check whether the data is within the legal range. The next slide provides an example. Suppose we want to check whether month is between 1 and 12. And we want to check whether day is between 1 and 31. Then you can perform the check inside the braces. So usually we use initialization section to initialize member data, and we can check the range inside the braces. And the next slide is about constructor overloading. We already learned function overloading. So we learn function overloading in previous chapters. In this chapter, and overloading means functions can have the same name. So you can define many functions with the same name, but with different parameter list. So you can define many constructors with different parameter list. So here we have 3 constructors, and each constructor has different parameter list. The first one has 2 inputs. The second one has only 1 input. The third one has no inputs. The third one is known as default constructor. If the constructors has no inputs, then this constructor is called the default constructor. So here we already implement the first version. So this version has 2 inputs, and we use the 2 inputs to initialize the member data. And you can perform, you can check each member data inside the braces. So here I call a member function test date to check the member data. The second version only has 1 input. So this input is used to initialize months. And the other member data day is set to 1. You can choose any integer you want. And for the default constructor, this constructor has no inputs. So here, member data are set to both are set to 1s. And now you can do some experiments about the constructors. So here is one example. Here I follow the slides. I define 3 versions of the constructors, and you can start to use the constructors. So here I declare an object, and followed by a parenthesis. So this will call the first version, because this function call has 2 inputs, and I also declare data2. Data2 will also call the constructor. This will call the second version, because this one has only 1 input. So data2 will invoke the second version of the constructor. So here data1 prints 12, 11. The output will print 12, 11, and data2 will output will print 12 and 1. So month is set to 12, and day is set to 1. So here the value of day is 1. And then you might wonder how to call the default constructor. So here, how do you call the default constructor? So I think this is easy. You just copy this. So here we call we want to call the default constructor. So here we have no inputs. Then you start to compile the code, and you will find a syntax error here. You will find syntax error here. So this means you cannot call default constructor like this. This will lead to this will have some problem. And then you can try to debug where the problem comes from. And if you comment out this line, so here the error, the error message is from the 15 line. So here, so this line, dat3 dot output, leads to syntax error. The error message says dat3 is not a class. It's not a class type of day of year. So here this means data3 is not an object. So here you cannot run this line because data3 is not an object. And this means you do not create data3 in this with this line. So the problem comes from this line. The correct way is to remove the parentheses. So if you want to call the default constructor, you need to remove the parentheses. So this time you can run the you can compile the code. So data3. So here we have no parentheses, and this will call the third version. So month is set to 1, and the day is set to 1. And if you call the output, so here prints 1, 1. So this is the common mistake mentioned in this slide. When we want to call the default constructor, you cannot add a parenthesis because this has a different meaning. This means you want to declare you want to declare a function date1. This function has no inputs, and this function return a variable of data type, day of year. So this is a function declaration. So you see, if you write expression like this is to declare a function, not to declare an object. So this is a common mistake for beginners. So if our purpose is to declare an object, we should use the first one. So no parenthesis is after the object name. So this is a bit confusing, confusing because for 2 inputs or 1 inputs, we use parentheses, but for no inputs, you cannot use parentheses. So this is a bit confusion for beginners. The next slide is about you can explicitly call a constructor, and to explicitly call the instructor, you just call this constructor like a function. You don't need to use object, so you don't need to use holiday dot day of year. You just call this constructor. So this is called the explicit constructor calls. Previously, this usage is known as implicit constructor call. And if you want to explicitly call a constructor, then just use it like a function. So here is like a function. This function will return an object of data type day of year, and you can assign the return object to another object. So this is known as the explicit constructor call. And if you want to call the destructor, if you want to call the default constructor, you can call the you can make a explicit call like this. So this is a function, so you need to add the parentheses because this is a function. If you remove the parentheses, the syntax this will lead to syntax error because you cannot assign a data type to some variable. So the next slide is about a self-test exercise to test your knowledge about constructors. So in this exercise, we define a class, your class, and we have 2 constructors. The first constructor accepts 2 inputs. The second constructor is the default constructor. This constructor has no inputs. And then in the next slide, you need to determine which declaration is legal. So the first 3 statements are implicit constructor calls. So for implicit constructor calls, you need to choose the, here legal means semantical legal, which means we suppose our purpose is to declare objects. So which of the following 3 statements are legal? clearly the first one is legal because this first one corresponds to the first. The first one corresponds to the first constructor, and the second one we already talked about this. The second one is not its semantic is not legal. Its syntax is legal because you can compile this code. The syntax is legal because you can, for this example, you can compile this code. So you see, so here we can compile this code. The semantic is legal. The syntax is legal because we can compile the code. However, you do not create an object because this is a function declaration. So this is a function declaration. Data 3 is a function with no inputs, and the return an object, day of year object. So this is a function declaration. So this is not what we want. So its semantic is not legal because this is not what we want. This is only a function declaration. And if we want to call the default constructor, we need to use the third statement. So the third one is legal. This will call the default constructor. So this will call the default constructor, and this default constructor will initialize the member data information and the more information. Information is set to 0, and the more information is set to character A. And let's consider about the following three statements. So the following three statements explicitly call the constructors. So the first one is legal. We treat constructor like a function. You can directly call the function. So we call this constructor. So the first one is legal. The second one is also legal. We directly call the default constructor. And the third one is illegal because your class is a data type, and you cannot assign a data type to some object. So the third statement is leads to syntax error. And we can modify this example to use the explicit constructors. So here you can so here we can do a experiment. So first I create date 3 object, and this will implicitly call the constructors with 2 inputs. So when you print the member data, month is 12 and day is 11. Then I explicitly call the default constructor. So here I explicitly call the default constructor, and this will return an object. And this object will be set to 1 1. Month is set to 1, and the day is set to 1. So this constructor, this default constructor will return an object. This object is assigned to date 3. And if we output the member data, so month is 1 and day is 1. And because we call the default constructor. So you can either use the implicit way or the explicit way to call the constructors. So here you cannot omit the parentheses. This leads to syntax error. Because this is a data type, you cannot. Data type is used to declare variables. So the compiler expect some name after this data type. So you see the error message. There should be some expression before the semicolon. So if you want to explicitly call the constructor, you need to add the parentheses. And the next slide talks about a question. This question is about whether the compiler will automatically generate the default constructor for you. So this question is whether the compiler will automatically generate a default constructor. And the answer is yes and no. So if you do not provide any constructors inside your class definition, if you do not provide any constructors, then the compiler will generate a default constructor for you. However, if you provide any constructors inside your class definition, if you already define some constructors, and then this time the compiler will not generate the default constructor. So you can test this by yourself. The next slide is about class type member data. So previously our member data is built-in data type is integer or double. However, you can use class. You can use your own data type. So here the private data, the member data is of day of year. And suppose you want to initialize class type member. You can still use the semicolon. You can use the initialization section, and the syntax is the same. Here, you know that date is an object of day of year, and now we want to initialize this object, so you can call a constructor. So here, you see date is followed by parentheses. So this will implicitly call the constructor. So this will implicitly call the constructor of day of year. So here, we have day of year here. So the implicit code will call the constructor with 2 inputs. So you see the syntax is consistent for built-in data types and for class type members. So you can use you can see the consistency of the syntax. So you can always use this initialization section method to initialize built-in data types or initialize class type member data. Time is up, so let's take a break for 10 minutes. Hello. Let's continue our class. The next slide is about parameter passing. Suppose you want to pass a class object to some function. You can either use call by value or call by reference. And we already talked about this before, so I will skip this. The next slide is about the const keyword. We already know we already use the const keyword. So for example, you want to protect your input parameter. So suppose you add the const keyword here. Then this means you cannot modify this input inside the function definition. So the purpose of the const keyword is to protect the parameter. And similarly, you can use the const keyword to protect the member data. So if you add the const keyword after some member function, then this means you cannot modify member data inside this member function. So here I add const after get months. This means I cannot modify months and the day within this member function. So we can do some experiments. So here I need to add the const keyword. So here in this implementation, you also need to add the const keyword. So you see here get day. So here get day is the accessor. You can access. This accessor returns the member data day, and the value of data is 1. Because the default constructor sets day to 1. And you can do some experiments. Now suppose you want to modify day. Suppose you want to modify months. So you perform months plus 1 inside this accessor. Then you will get syntax error. Because this const modifier protects your member data, so you are not allowed to modify member data inside the const function. So you see the error message. So months is read only inside this member function, because this function is a const member function. if you remove the const keyword, then you can modify member data inside this function. So you see here, you can compile this program without error message. So const member function do not modify the member data. So here, this is the member data of the calling object. You will use some object to call the member function, and the const member function does not modify the member data of the calling object. The next slide is about the second keyword in line. If your function definition is very short, so for example, your function definition is very short, then you can move the function definition inside the class definition. So you can move function definition inside the class definition. This is known as inline member function. So for our example, I can move the function definition. So here is the function definition. Then I move this function definition. So here is the this is only a declaration. So here I move this function definition of the member function getDate. So this is known as the inline, because you move the function definition inside the class definition. And you don't need to add the scope resolution operator, because it is already inside this class. So you don't need to you don't need to use the scope resolution operator. So here we can use this accessor. Or suppose you don't want to move the function definition, you can add the inline keyword before the return data type, and this keyword means you want to move the function definition inside the class, day of year class. So if your function definition is very short, you can consider use the inline member functions. And then I will introduce the static member data. This is the last topic in this slide. We can begin from one example. So here we use day of year to declare two objects, date 1 and date 3. So date 1 is set to 12 and 11, and the date 3 will call the default constructor, and is set to 1 1. And we know the member data of date 1 and the date 3 are independent. So data 1 has its own member data, and data 3 has its own member data. And sometimes we want to share member data across all objects of the same data type. So sometimes you want data 1 and data 3 to share some member data. And if you want to do this, you can use the static member data. So static member data allows all objects of the same class to share variables. If one object modify the static member data, then the other objects can see the change. And this is useful for tracking. For example, you want to know how many objects are created, or you want to know a member function is called how many times. So you can use static member data for tracking. And next, I will use one example to illustrate how to use the static member data. So here is the example. So here we declare number objects. So this is the member data, and we use the static keyword before the integer. So here we add the static keyword. This means this data is shared across all objects of the day of year class. So static member data means this data is shared across all objects of day of year class. And then we need to initialize this static member data. You cannot use constructors. So here you need to directly initialize this static member data outside the class definition. So here we initialize static member number objects to 0 outside the class definition. And then you can access the static member inside any member function. For example, inside the constructor, besides initialization, we also increase the static member data by 1. So actually we are tracking how many objects are created. So if this constructor is called, then this variable will increase by 1. So you can use this value to know how many times this member function is called. So we can start to try to implement this example. For convenience, I put this data in public. So for convenience, so I can directly print its value. So here we increase the static member. So here is the static member. And if we call this constructor, then this static member will increase by 1. And its initial value is set to 0. So here, after data 1, after create data 1, I print the value of this static member. Its value is 1. Because I call this constructor, and this constructor will increase the static member by 1. So you see after this constructor call, its value is increased by 1. And then after another constructor call, the static member number of objects is also increased by 1. So this object is shared by all objects. So if you modify this static member inside data 1, this member is also shared by data 3. So data 1 and data 3 share the same number of objects. So here I create another object. I create another object date2, and the date2 does not modify the static member, because here I call the default constructor. So here I call the default constructor, and default constructor do not modify the static member. So you see the value of number objects remains the same, remains 2. So if we want to track how many objects are created with this 2 input constructor, then you can use the static member data. And here we also have the static member function. So here is the static member function. So here is the static member function. Static member function means all objects can even without objects, you can directly use this member function. So this is called static member function. So here we add the static keyword before this function declaration. So this means we can call this function without objects. So here you see we can directly call this function. So we make a function call get number objects. We do not use any object. So you don't need to for other typical member functions, you require some object in order to use member functions. But for static member functions, you do not need objects. You can directly call the static member function. And the static member function can only access static members. So here you can only access static members. You cannot access non-static members. So you cannot access months or day here. Because if you do this, then this function call will have problem, because this function call does not involve with any objects. So here we can do the experiment here. So because time is limited, so I will skip the demonstration. So you can try to implement this static member function by yourself. So this page summarizes static member function. So we can use we do not require objects to call a static member function, and this function can only use static data. You cannot use non-static data inside this static member function. If you do this, this will cause syntax error. And we have finished the constructors. Then we will return to our previous slides. So we will return to here, pointers and dynamic arrays. So we have some topics. We have some topics related to constructors in these slides. So let's see this slide. So in this chapter, pointers and dynamic arrays, we have 3 topics, and we already finished the first 2 topics, and then we will go to the third topic, classes, and we will talk about the big 3: the destructors, copy constructors, and assignment operator. So here is the big 3 for a class. So the big 3 is the default constructor. One of the big 3 is a default constructor. Here we call the constructor without parentheses. So you know this will call the default constructor. And the second one is copy constructor. We haven't learned this. So you see, str2 is followed by a parenthesis. So this will call the constructor. And this is a special type constructor. This is known as copy constructor, because the input data is the same as the object we want to declare. So because the input str1 has the same data type as str2, so they are of the same data type. So such constructor is known as copy constructor. And later I will introduce copy constructor. So this means you copy one object, you copy str2 from str1. And the third one is known as the assignment operator. Operator is also a member function. You can implement this assignment operator. So the big 3 contains copy constructor, assignment operator, and big 3 contains also a destructor. And it is called big 3 because if you need any of them, then you need all 3. Suppose you implement the copy constructor, then you also need to implement the assignment operator and the destructor. When will you need to define the big 3? This is for when you use the new operator. Suppose you want to allocate memory inside the copy constructor, then you need to define the big 3. So this is the principle. If you allocate memory inside some class, then you need to define big 3. You need to define copy constructor and the destructor and the assignment operator. Later we have one example. So you can find this example. You can copy this example. First is the default constructor, because this constructor has no inputs. And we also have a very special constructor. This is the copy constructor. So you know the input parameter. Its data type is the same as this class. This class is partial field array, PF array. So the input parameter has the same data type, PF, partial field array. So this is known as copy constructor. And here we use call by reference for efficiency. So we add the ampersand operator. And we also have another constructor. So this constructor has one input, and the input is an integer. And we can see the function definition. So here is the function definition. This is the default constructor. So this constructor has no inputs. And our member data is two integers. The first integer is the capacity of this array. And the second member is also an integer used. This denotes the size of this array. So used is the size of this array. Capacity. This is similar to we already learned vector. Vector has capacity and the size. And we also has a pointer, A. So A will point to the allocated memory space. So we have three members for this data type. And inside the default constructor, capacity is set to 50, and the used is set to 0. And this means we will allocate 50 doubles. So here we use new to allocate 50 doubles. And the new will return a pointer. This pointer is assigned to A. So A is point to the memory space we allocated. And in this default constructor, we allocate 50 doubles. And if you supply one input, if you supply size, then size will be used to initialize capacity. So capacity will be set to size. And we also have the destructor. Destructor, we add a tilde. After, you see, destructor has the same name. The destructor, so here is the destructor. Destructor has the same name as this class. And besides, we have to add a tilde before the class name. So this is the destructor. And for destructor will be automatically called when the object is out of scope. So this is in contrast with constructor. So when we create an object, we will call constructor. When an object is finished, then we will call the destructor. So because we allocate memory space manually, so after the object is destroyed, you need to return the memory. So you need to return the memory in destructor. So here we use the delete operator to return the memory. And because A points to an array, so you need to add the brackets before A. And then we need to implement the copy constructor. So you see, the input of the copy constructor is its name is PFA, and its data type is partial field array D. So this data type is the same as this class. So this is the copy constructor. And so here we use PFA.capacity to initialize the member data capacity. We use the PFA.used to initialize the member data used. And then we need to allocate memory space. So here we allocate memory space to the we allocate memory space, and the pointer A is points to the allocated memory space. Then we need to perform element-wise copy. We need to copy each element in the input object PFA. So here the for loop performs element-wise copy. So you see, for copy constructor means copy constructor is a constructor that has one parameter of the same data type as the class. This is the definition of the copy constructor. And it is usually, it must be called by reference, and usually prefixed by const modifier. So we have two types of copy. One is shallow copy, and the other is deep copy. So what we see before, this one is deep copy. So if you perform element-wise copy, this is deep copy. So the element-wise copy is deep copy, and you have also another choice. You can perform shallow copy. Shallow copy is to perform pointer assignment. You assign pf.a to A. So this is pointer assignment. This leads to shallow copy. And I will use some figure to illustrate the difference between the two copies. So here is the figure for deep copy. Suppose we create PFA1 with two elements. PFA1, this will call a constructor to allocate it two doubles. Then you can use add element to add two elements. Then you want to you want to copy PFA2 from PFA1. And if you use deep copy, so this means PFA1 will point it to a located memory space, and the PFA2 will point to another located memory space, and you perform element-wise copy. So so the first element will copy to the first index 0, and the second element will copy to index 1. This is called deep copy. However, if you perform pointer assignment, if you assign point pfa.a, this is a pointer. So here A is a pointer. So here A is a pointer. So if you perform if you assign pf.a to a, this is pointer assignment. So this means pfa2.a will point to the memory space allocated in pfa1. So shadow copy means we do not allocate new space. We just create. We just use pointer assignment. So this is the difference between shadow copy and deep copy. And the result is that if you modify pfa2.a, this will affect pfa1 because pfa1 and pfa2 share the same memory space. So if you use shadow copy, then pfa1 and pfa2 will share the same memory space. However, if you use deep copy, then pfa1 and pfa2 will have its own memory space. Here we can do some experiments about this example. Then we copy the function definition here. Because we do not sufficient time, so you can look the definition of 8 element by yourself. So now we can start to use this object. So we can start to create object. we need more functions to display the allocated memory. So here we also need show array. You can download the code from the reference web page. So here we have the reference web page, and you can go to pointer and dynamic arrays. So here is the partial field array. So you can download this CPP file. So here you see I create PFA1, and I add 5 elements. And here we use PFA1.showArray. You can print the 5 elements. And then we perform, we call a copy constructor. So PFA1 is copied to PFA2. And then we modify PFA2. So the first member is modified to 1.2. So you see, if we print PFA2, the first element is modified to 1.2, and PFA1, the first member of PFA1, remains the same. This means this copy is a deep copy. So here, the copy constructor performs a deep copy. And if you modify the function, if you modify the deep copy to shallow copy, so here I will try to modify the copy constructor. So here is the copy constructor. Then suppose I do not allocate memory space. And suppose I just perform pointer assignment. So here you see I just perform pointer assignment. Here I do not allocate memory space. So here then PFA1 and PFA2 will share the same memory space. And you will see if you modify PFA2, PFA1 is also modified. So you see here, I modify PFA2. The first element is set to 1.2. And the first element of PFA1 is also modified to 1.2. Because PFA1 and PFA2 share the same memory space. Because the copy constructor is shallow copy. So you can use this example to test shallow copy and deep copy by yourself. This example also includes operator overloading. and this will not be included in our exam scope. So you can skip operator overloading. This will not be included in our exam scope. So this slide is also finished. And here I have one additional question for you to practice. So here is a question about constructors. So here is the definition of a class, and here is the definition of the constructor. And you need to after we create this object, then you need to determine the value of my.x and my.y, and you can try to compute the answers. So the answer, I think the answer is the first one. So my.x is 0 and my.y is also 0. When you declare this object, this will call the default constructor. So here is the default constructor. So -1 is assigned to x, and -2 is assigned to y. And also you note inside the braces we have the function call. So this is the crop member function. So here is the definition of the crop member function. So if x is less than 0, then x is set to 0. Y is less than 0, it is also set to 0. So both are negative. So both x and y will be set to 0. So for this question, the answer is 0, 0. So you can try to practice constructor like this. I think the lesson has come to an end, and the class can be dismissed.